Hello and welcome. This is Matthew, and today we are taking a slight departure from the normal content here on the channel. We're just going to do some basic introductory programming lessons. I have some friends who are looking into learning JavaScript, and I know there's a lot of tutorials online, and those are good when you want to see how to, build a particular type of site or implement a particular type of game. But I think a good starting point is just really kind of from scratch, how do programming languages work, right? What are just the very kind of minimal basics of JavaScript so that hopefully with a little bit of foundation, jumping ahead and looking at some of those other tutorials, some of the underlying concepts will make a little bit more sense. So if you're here for the mainframe content, you can certainly skip this video. But if you're interested in JavaScript, either as an existing programmer who hasn't looked at JavaScript, or even if you've never really programmed before, hopefully this just plants some seeds for the basic ideas of how programming works. So JavaScript as a language really came into being to be used on the web. Don't be confused with the Java language. Java and JavaScript are entirely unrelated. They just happened to emerge around the same time. And one of the ideas with Java was also that you would build applets for the web. That aspect of Java never particularly took off, even though Java became one of the dominant programming languages, certainly in industry for business. But nevertheless, JavaScript is the language that people can program sort of the interactive dynamic features of web pages. And it lives on to this day, and the language has evolved quite a bit. As a language, it's not my favorite, but really when it comes to web programming, you don't have a choice. You are going to be using JavaScript for your front end, certainly. So to that end, the way that we will play around with JavaScript, even though we're not going to be looking at HTML or CSS or any kind of web programming or even making anything on a web page happen from JavaScript today, we're just going to be focusing on JavaScript, the language. The way we're going to do that is by using our web browser to run our programs. So I have two files here. One is an HTML file, so a web page, and this web page exists for the sole purpose of loading and running our JavaScript code. So as you can see on my web page, I just say there's nothing here. Look in the console log. We'll look at what that console log is. But the important thing is this web page is including this JavaScript file using the script tag. And the source of my script is the file lesson.js. So I have another file open here called lesson.js in the same directory. And this is where I can put all of my JavaScript code. So with that, again, these are just files on my local hard drive in the same folder. And over in my web browser, I'm using Chrome here. If I hit Control-O to open a file, and if I navigate to wherever that file is, I'm already here in my lesson folder, and I open the HTML page, I will see my web page. I'll see that HTML file. JavaScript demo, there's nothing here. Look in the console log. So it ran this JavaScript file, which is supposed to say, hello world. And the way we see that is by opening up the developer tools in Chrome. So under the little Chrome menu here, if you go to more tools, you can turn on developer tools. And the shortcut for that is Control-Shift-I. And that pops open the Chrome developer tools. Now, I think by default, it will be opening over on the side. So I always change it with these three dots down to the bottom. That layout works a lot better for me. And then especially the way I have these windows laid out, this will make it easier to read. And sure enough, we can see it ran this one-line JavaScript program, console.log hello.world. Not hello.world, hello world. And it printed out in this console here. So there's this thing called console. It has a function called log. and whatever text I put in there is going to pop out in this log. So if I say console.log hello again, and I save that file, and if I just refresh the page here in the browser, now when it runs my program, it prints hello world and hello again. So I put that text in these single quotation marks. That makes this whole thing a string. So this is a string parameter that's being passed to this function. And we'll talk more about functions and types and variables and all of that. But a couple things to note about JavaScript is that you can use either single quotes or double quotes. They just have to match. So I can say double quote hello world. I can say single quote hello again. If I save that and I reload, it still works. Nothing's changed. JavaScript also, in a lot of C-derived languages like JavaScript, you have to put semicolons at the end of your statements. So if I reload, that still works. But JavaScript removed the hard requirement to have semicolons. So as long as there's no ambiguity, you can just leave the semicolons off and it figures it out. I think traditionally you would have seen more double quotes, but from what I've noticed in a lot of current programs, the JavaScript standard seems to be drifting toward using single quotes and no semicolons. Much of my experience in most programming languages leans toward double quotes and semicolons. So you may see me, intermingling using semicolons and double quotes versus trying to remember kind of, keep up with the kids these days and use single quotes and no semicolon. Really with programming, you can pick a style that works for you, but the goal is consistency. So, me intermixing like this is less than ideal just from a stylistic perspective. Nevertheless, be aware that you kind of have all of those options. Something else to point out is, hello world, I'm doing well. I used an apostrophe, that single quote mark, in this text, which, because I'm using double quotes here, will work just fine. So let me save that and let me refresh that. Hello world, I'm doing well. If I do that down here, hello again, I'm still doing well. You sort of get a hint. I'm using VS Code here as my editor, and it's helping me out by highlighting potential problems and doing some syntax coloring. But if I save that and reload here, you're going to see I get a syntax error. And that's because JavaScript thinks I opened this block of text up, the string. I said, hello again, and then it thinks that this apostrophe or this single quote is the end of that string. And it has no idea what to do with the rest of this. So there are two ways to fix that, right? If I know I'm going to be using a bunch of single quotes inside my string, then I can change those to double quotes. And that's one of the nice things about having the flexibility to use one or the other, is while you want to be consistent, sometimes it actually makes sense to use a particular type of quote for convenience reasons. And that's a good reason to not be consistent in one particular place, because it makes the code more readable, being able to use a single quotation mark without having to do anything weird to get around the fact that you were also using single quotation marks out here. But the other way to do it is called escaping. So you escape characters by putting a backslash in front of them. What that says is, this next character that I'm about to give you, I don't want it to do what it normally does, right? I don't want it to close this quoted string. I actually want to include that single quote in my text. So if we save that and run that, you can see, hello, I'm still doing well. Similarly, if I am saying, hello world, can you say, hi back to me? because I'm quoting hi, these double quotes, I'm running into that same problem. It thinks I'm ending this double quote. Well, that's not what I'm doing. I need to put a backslash in front of that to escape it. And now it will be treated as if I had just put in the double quote in the text. And there we can see it works. Hello world, can you say hi back to me? That, of course, raises the question, well, what if I just want a backslash in the text, right? Hello world, can you type a backslash? Well, in this case, it thinks I'm escaping the question mark. So if I reload that, it works, meaning I don't get a syntax error. The program runs, but there is no backslash. It just thought I was escaping that question mark. So, of course, you may have guessed it. The way you escape a backslash is you put a backslash in front of it. So here, I'm saying, don't do the special thing that backslash does, right? I'm not trying to use backslash as an escape. I just want a backslash. So let's refresh that. And sure enough, now it prints out one backslash because I escaped that backslash. So that's printing out. All right, so this wasn't necessarily meant to be a deep dive on string syntax initially, but I just wanted to point out that you may see these two different ways of quoting strings. And one of the reasons you may want to use one or the other depends on if you want to use that character inside of your string. But let's back up a bit to just, more of the fundamentals here. As you saw, and again, we're just going to keep using this console.log function because it's a convenient way to get stuff out of our program. Programs run from top to bottom. So if I say line 1 and then I say line 2, they of course come out line 1, line 2. One of the more important concepts in programming certainly is the idea of variables. So variables are names for things that can hold a value. And technically the variable isn't the name, but it's kind of easier to think of it that way. So the current best practice of making a variable in JavaScript is with the let keyword. So I use let to give a name to something. And I can say let color, and then I can say equals, and we'll make it the string blue. And we might say let food equals taco. So this is creating a variable called color, and it's putting the value blue as a string, because it's in these quotation marks, into color. And now I can use that variable to get this value back out. So if I say console.log, and then instead of typing blue, if I type color, I have now made this word color, this special thing, this variable, which at the moment happens to have the value blue. So let me delete my line 1, line 2, just so we're not getting confused. If I save that and I reload, you can see it prints out the word blue, because that's the value that color currently has. Of course, I can do the same thing for food, and that will print out another line with food, taco. And I can change the value of the variable. So we first made it blue, now let's say red. And now if I print it out again, we've changed the value of color from the string blue to the string red. And again, up here, because I haven't changed it to red yet, because the program runs from top to bottom, I'm getting the color blue printed out. And then the program keeps going. The computer says, I now need to put red in the memory wherever it's storing color in memory. So now when I ask to print out color again, I get red. There are a number of ways to make these variables in JavaScript. So we said we can use let. You'll also see var, short for variable. And on the surface, it looks like this does the same thing. Let's just print out color again. And you can see it works, blue. There are a number of differences between var and let, and I can show you some of those in a minute. But just know that unless you have a particular reason you need to use var instead of let, you should always be using let in new code that you're writing in modern JavaScript. You can also say const for a constant. And this, again, with this sample, if I reload, it looks like it does the same thing. The difference here is if I now try to change color to red, and we'll print it out again. Now I have an error. I tried to change a constant variable. So a const is a constant. You're giving a name to something that you don't want the program to be able to change. Why would you do that? Why would I do const color equals blue instead of just saying, hey, if color is always going to be blue because I'm saying you're never allowed to change what color is, why don't I just do that, right? Why use 2 lines when I can just use 1 line and I can print blue? The answer starts coming if you think about the fact that you may need to say that in lots of places, right? So if I say const, game title equals my cool game, and if I say something like console.log welcome to, and then we'll see something new here. If I want to add strings together, I can actually just use the plus operator. So instead of adding 2 numbers together, this is attaching 2 strings, this string on the end of this string. And if we run that, it says welcome to my cool game. And we get the space between welcome to and my cool game because I included that space there. And if I didn't, the computer's very literal. It will take this string, so everything inside those quotation marks, and this string, everything inside those quotation marks, and we'll get that sentence without a space between there. So we fix that by just including the space there. But this is called string concatenation, just basically stringing strings together. And I can just keep on going, right? I can say, welcome to my cool game. I hope you enjoy playing. And that should end up being a correct sentence. Yep, welcome to my cool game. I hope you enjoy playing. So that's how kind of gluing these strings together works. You can just add them together, but it's not an arithmetic addition like with numbers. It's a string concatenation operation. But the point we're making here is you may then, you have your game here. The person plays the game. And then at the end of the game, you can say console log, thank you for playing. And we can put game title back. So let's save that, run that. So here we go, right? At the beginning of the game, welcome to my cool game. I hope you enjoy playing. At the end of the game, thank you for playing my cool game. Now, because we made that game title this constant variable, right? It's not something that we want to let JavaScript let us accidentally change, right? The name of the game is the name of the game. We don't want to, make a mistake and, for some reason, thinking that we're maybe doing something else, changing the title here. We'll get that error again. But the advantage of just typing my cool game here and my cool game here is that if I do decide to change the name of my game, my super cool game, now by just making that change in one place, everywhere where I need to print out the name of my game gets updated automatically because I'm using that variable. So again, maybe this is a bit of a contrived example, but this is a good way where if there are certain values that you as the programmer are defining, but they should just always be used throughout the program, you don't want to have to keep repeating that same value. These constants are, that's why these constants exist. It's so that you can give a name to something and then you use that name, but whenever you want the value to change in your program, you can just go and change it in one place. Some other realistic examples of that might be if you are writing a program that, I don't know, I said realistic, but let's just make something up. If you're writing a program, let's say a game again, right, that involves a spaceship and, people are able to get on the spaceship. You might want to say, max people on ship. And maybe you want in your game, ships can hold up to 50 people. Now, you might have a lot of code throughout your game, checking, can another person come on board? When you are at the space station, right, and you want to let your player, let people from the space station onto the ship, you're going to have code that only lets the player invite more people onto the ship if the ship isn't already full. And if you are then flying to a planet and you want to, beam people up from the planet, well, your game should only let the player beam people up from the planet if the ship isn't already full. And in a more complicated game, of course, you might have different types of ships that have different, numbers of maximum players. But if it's simple, if it's just one ship in the game, it's nice to be able to have one spot in your code where you define what is the maximum number of people that can fit on a ship. And that way, if when you're playtesting or you decide you want to change your game, you say, you know what, the game works better if you can only have 25 people on your ship or 80 people on your ship. You can just change the constant that you've defined, usually toward the top of your code, so it's easy to see when you're coming in and changing the code. You change it in one place, and then you're able to use that number in all of your other code that needs to be aware of how many people fit on a ship. So those are constants. Let's see. We talked about constants. We talked about let. We talked about var, food equals taco. The other thing JavaScript lets you do is not use any of these. And this is bad. So I can just say, let's say car equals Tesla. This is perfectly valid. We can add a line here that then uses that variable. My car is we'll add car there. So let's reload. If I run that, it works. My car is a Tesla. The problem with this is it leads to very error-prone code, for one thing, and that a lot of languages require that you declare your variable. So the first time we say this variable exists, right, I'm bringing this thing called color into existence, and I'm using a word like let or const or var. That's called declaring a variable. You're telling the program that I want this thing called color to exist. In this case, I didn't really explicitly tell JavaScript I want this thing called car to exist. I'm just assuming it exists, and I'm setting it to the value Tesla. Now, that's convenient, but if you're used to a lot of other programming languages, again, this would be an error, right? It'd say, hey, there's no such thing as car. And that prevents me from making, typos, perhaps. So, right, if I declare my variable color, and if later on I want to change color to red, all right, and then I console, log the new color is plus color. Let me just delete the rest of this. Yeah, that's fine. Okay, so let's run that program. We have a problem here. The new color is blue, right? So that makes sense. So I set color to blue, but then I thought I set color to red. It should be printing red here, right? Well, no, you may have noticed I made a typo down here, right? I meant to change this thing called color. But in fact, I created a new variable called color, more colorful, I guess, with that extra R on the end. And JavaScript just happily let me do this because it doesn't require that you explicitly declare variables. It, in fact, created what's called a global variable, which we haven't gotten into scope yet. But not only is this an undeclared variable, when you do create variables this way, they have global scope, which means they are available anywhere and everywhere in your entire program. And programming with global variables is considered very bad practice. You want to keep all of your logic contained and encapsulated into either the function it's in or wherever in the code it is. You don't want your code in this file dealing with colors to be, changing state, making variables available, maybe hundreds or thousands of lines later, maybe even in a different file entirely that has nothing to do with colors. But JavaScript, especially old original JavaScript, let you make variables this way. So we never want to do this. We, in fact, in modern JavaScript, can put this magic string just as a string on its own at the beginning of my program to say use strict. This says I want JavaScript to be more strict about how I'm programming. And this is good because this will prevent accidental bugs that otherwise might slip through unnoticed until you try and run, until they cause an actual problem. So let's refresh this. Okay, so since I'm in strict mode, now JavaScript is angry at me for using this variable that doesn't exist. So I would say, oh, well, I thought it does exist, right? I declared it here. I have this thing called color. But this is going to bring to my attention the fact that, oh, no, right, I must have made a mistake. I mistyped color. I meant to set color equal to red. And now if I run this, it does what I think it should do. It was first set to blue. I changed it to red. So now when I print color, we get red. So always use this as the first line of your program. Use strict. I can't think of a time when you wouldn't do this, right? Unless you're dealing with really old code, but at that point you should probably just rewrite the old code to actually work in strict mode. If there's a situation where you shouldn't use strict, then you should have a reason for that. But certainly as a beginner, I can guarantee you aren't going to be able to think of a reason when you shouldn't be in strict mode. Okay, so that's variable declaration and strict mode. I said, right, the difference between let and var, just use let. That's kind of the rule. The difference, to use some concepts that we haven't covered yet, but let is always scoped to the block in which it appears. And I'll show you what this means pretty soon. Var is in the scope, if it's in a function, the var scope is at the function level. There's also some nuances with var versus let redeclaring things that you have in an outer scope. This is hard to talk about when you don't necessarily know what scope is and what some of these words mean. So let's maybe put a pin in that, and I'll return to it when we actually introduce some scope here. But what you need to take away is when you're making a variable, use let. Or if it's something that doesn't change, if it's data for your program that you want to just set up initially in your code, you can use const. So those are the two types of variables you're going to use, const and let. So we said the program runs from the top to the bottom, starts on line 1, runs line 2, runs line 3, so on and so forth. That doesn't lead to being able to write very big programs very efficiently, or even small programs in a way that's nice and sensible. So the first exception to the rule of running top to the bottom, and it's not really an exception, but there are these things called comments. So I can write notes to myself and others in comments. And anything that is a comment just gets skipped over, right? So these are notes to humans. Why did I do what I'm about to do the way I did it? There is certainly an art to commenting code. You don't want to write comments that are blatantly obvious, right? So if I say let a equals 1, let b equals a plus 1, and then add a comment here, add 1 to a, this comment does nothing to increase my understanding of the program. I can read the code, and the code is obvious enough that I am adding 1 to a here. So that's just noise and gets in the way. A good use of a comment is to describe something that is perhaps non-obvious, or to make a note as to why a particular algorithm works, or what a particular function does. There's an argument that if you have to really describe it a lot in a comment, you should try to rewrite it so that the code itself speaks better about what it's doing, is more obvious. But again, this is just something you pick up from experience, from seeing other code that you like and makes sense to you. You'll kind of pick up where, kind of how people are using comments. But for now, know that you can put text between a slash star and a star slash, and anything inside of here is a comment. So it just gets skipped over when the program is running. You can also do single line comments with 2 slashes. So at the end of a line, add 1 to a to bring back our bad example of a comment. These slash slash just makes the rest of the line a comment. And so for quick inline comments, you'll see that. I can also do that at the beginning of the line. Here's a single line comment. And you'll see, people do whole paragraphs this way. Here's more text and even more text. This is a pretty common way to do it, just because, especially if you don't have the color highlighting in your text editor, this type of comment can just stand out and be a little bit more visible than if you had made a multi-line comment like this, just with that comment start and comment stop character, right? If I'm reading through the code, this style kind of makes it more visibly apparent that this is a block of some explanatory text, versus this can look a little more messy, right? People do cute things to sort of line up and make it try to stand out a little more. There's a lot of different style philosophy in terms of, if trying to do this kind of alignment stuff is silly, if you put little additional asterisks here to kind of call out that block and indent this a little bit. So again, as you look at more code, you'll see a lot of different ways people are kind of formatting and styling their comments. But fundamentally, 2 slashes makes the rest of the line of content, and slash star and star slash make everything between it, no matter how many lines long it is. Visual Code tried to help me out there. Makes everything in there a comment. The one thing to be careful of is I can't use slash star as text inside of a comment, because that ends the comment. And there's no way to escape that. This isn't like a string where I put a backslash in front of it. I can try and put backslashes in front of all of this. And although, did I just lie? Oh, apparently that, oh, well, sorry. Yeah, the reason that works is because it's no longer slash star. It's literally different text. But anyway, just, beware that can mess up your comments, which isn't a problem in this style, right? I can put as many double slashes as I want, because it just continues. The rest of the line remains a comment. All right, this is a bit all over the map. Sorry about that, but like I said, I just wanted to go through just some basics of kind of the syntax of the language and how it works. So we'll keep our use strict at the top. And let's talk about functions. So you make functions by saying the word function and giving a name to the function. And let's say this function is called say hi. And then you put parentheses after it, and you enclose the function body in curly braces. Now, right now, these parentheses are empty, but this is where the parameter list will go. So we'll look at that in a second. So what a function is it's a piece of reusable code. Anytime I want to say hi, which is to do whatever it is that I put between these curly braces, I'll just be able to call the function say hi. So we'll make a simple say hi function here, console.log hi. Now if I save this and I reload, nothing happens. So the program is still, right, it's still running from top to bottom. But what I'm doing in this program is I am defining this function. I'm telling JavaScript, hey, JavaScript, make this thing for me called say hi. This thing happens to be called a function. And whenever someone runs that function, do this. But I haven't actually called that function. So behind the scenes, JavaScript is going from top to bottom here. And when it gets down to my line 3 here and finishes up on line 5, out in the computer's memory somewhere, it has created this thing called say hi because we ran this code. Now I can actually call this function. So you call a function by just writing its name and putting the parentheses after it. So if I say that and reload, sure enough, now that I am calling or executing that function, it runs the code inside of that function and it prints hi. And of course, I can do that as many times as I want. And if we run that, it now runs this code 3 times because I called that function 3 times. And of course, I can have more than one line in my function. So now it should print hi bye, hi bye, hi bye, which it does. But the real power of functions starts coming from the fact that they can both take inputs and they can also provide an output value. So let's start with inputs. If I want to say hi to a person, I can create a parameter called name. And so name, it's a parameter to this function. And whatever comes in to name, when I'm inside of this variable, or I'm sorry, when I'm inside of this function, name is a variable that I can use inside this function. So I can say hi and then put the person's name in that string and finish off with the exclamation mark. And now when I call it, I can pass in a string and it'll just get plugged right in to this value. So I can say hi, Matthew. I can say hi, Lucy. I can say hi, Rocket. Rocket is my pet snake. And if I refresh that, you can see each time I call this function, it's using that value that I pass in through the name parameter. You can have multiple parameters into a function. You separate them with commas. I want to also accept the person's favorite color. I can say, hi, name. I hear your favorite color is, I'll put a space because I want that space to be printed out, and then plus the color. Now when I call the function, I can pass in the color. Right, and it just goes in order. So the first parameter to the function is name. The second parameter to the function is color. And I'm able to use those variables now inside my function. And it works as we'd expect. Hi, Matthew. I hear your favorite color is blue. I hear your favorite color is green. And Rocket's favorite color is pink. If we wanted to put, punctuation on the end of that, we'd just keep concatenating strings and get the period down there. There's other ways to do string interpolation and everything, but this is just a good, simple string concatenation approach. Okay, and there's our punctuation. So again, functions are really going to be the core of your program. Everything you're doing, you define your functionality inside of functions, and then you build your program up by calling functions. Functions can call other functions, and that's how you build out the entirety of your program. So the other thing functions can do is return a value. So if I write a function called add two numbers, and if we take variables called number1 and number2, or parameters called number1 and number2, I can, let's say we then say, okay, let sum equals num1 plus num2. And with what we're doing so far, let's just say console.log sum. Let's get rid of some of this other code. Now if I call add two numbers, I can add 4 and 10. Of course, I should get 14. Let's run this program. And sure enough, it prints out 14. Now, of course, again, this is a contrived example because I would always, just type 4 plus 10, right? I don't need to call a function to do math because I can always just directly do math in JavaScript, right? I can comment out this whole function so it doesn't even exist. And if I just say console.log 4 plus 10, I get the same output. So recognizing this is a contrived example, we're just going to use it to demonstrate add two numbers 4 and 10. We're going to just use it to demonstrate what functions can do. So instead of the function printing out the result, I can return the result to the caller. So this function takes two numbers and then it returns a value. So what does that mean? So now add two numbers is something I can set something equal to, right? So I can let my sum equals add two numbers, 4 and 10. And because this function returns a value, this new variable I made, my sum, is going to have the result of this function. So now I can say console.log my sum. And if we reload, you can see we're still getting 14 printed out. So now the number 14 is in this variable called my sum. So that's how functions work. You can give functions data that they can then use in their whatever they're doing, and they're able to return a value back out so that other parts of your program could then get the result of whatever logic that function performed. So let's talk a little bit more about, actually, let's do one more thing. Let's make a new function, and we're going to call this function, let's call it is Matthew, or I don't know, named Matthew. And this is going to take a parameter called name. And we are going to do some conditions now, right? So this is, I only want to do something if something is true. So in JavaScript, we have if. That's one of our conditional statements. If statements work by putting the condition you want to test for in parentheses. And just as a really basic example, right? So whatever goes in the parentheses needs to ultimately turn into true or false. It's called a Boolean value. It's either true or it's false. So if what's inside of the parentheses evaluates to true, which in this case, true is a JavaScript keyword that means true as opposed to false, then we do whatever's inside of the curly braces after the if. So we'll say here, it is true. And we'll call this function named Matthew. So if I run this program, well, true is always true. So if true, it is true. And that's what we see here. If we change that to if false and run this program, it does not say it is true because false, of course, is not true. Change it back to true, and it is true. So this lets you do something if that condition is true. You may also want to do one thing if it's true, but a different thing if it's false. So you can say else, and then put curly braces there, And now anything inside of these curly braces will happen when this condition evaluates to true. Otherwise, whatever's between these curly braces will happen. It is not true. Now, Visual Studio Code is actually smart enough to realize that a constant value will always evaluate to true, and so it's dimming out this code because this is unreachable code, right? There is no way running this program you could ever hit this code because you've just defined a constant true expression here. And like I said, Visual Studio Code is smart enough to realize, hey, this code is unreachable. So it's just making it dim in case we didn't notice that as well. But for our purposes, right, it works as a program. So it is true. If I change this to false, of course, opposite situation, it is not true. But this is generally silly because if you're just going to hard code in false, then you would just put this line and not bother with the rest of this. But what you can do is, of course, more interesting comparisons. So this function named Matthew, and here's I might document what this function does. Named Matthew will print what a great name if the provided name is indeed Matthew. Okay, so that's what we want this function to do. We're going to pass in a name. If the name is Matthew, we want to print what a great name. So here is where we can start using some of the comparison operators. So I have this variable name that's coming in. So I can say if name, and then I'm going to use 3 equals. And this is something that's kind of unique to JavaScript. If name equals the string Matthew, then I want to print out what a great name. Okay, let's run that. Let's try this first. Let's pass Matthew in. If I run that, it prints what a great name. If I say Matthew with, say, a lowercase m, it does not print what a great name because the string Matthew with a capital M is a different value than the string Matthew with a lowercase m. Excuse me. And then, of course, if I do a totally different name, it doesn't print either. We can add an else here. We can say that's a decent name, but not as cool as Matthew. Okay, so Bob's a decent name, but not as cool as Matthew. Matthew remains a great name. So far, so good. So this triple equal thing, generally in JavaScript, unless you know you have a reason not to, or you want to trigger this other behavior, it's safest to use triple equals. And this will behave more like other programming languages behave. So let's talk about types. If I say let a equals 5, I didn't put it in quotation marks, right? So this is a number. A is of type number. And in fact, if I hover my mouse over it, VS Code is telling me that. It's figured out that the type of A is number. Let's make B equals Matthew. All right, so B is of type string. B is a string. Now, I can't just say Matthew here because then JavaScript thinks, oh, you have a variable out there called Matthew, right? It's not a built-in word in JavaScript, and it's not a variable I define. So, in fact, if I just run this, I'll get an error, right? Uncaught reference error. Matthew is not defined, right? So numbers are defined in the sense that they just have their own identity. And numbers can be integers. They can be what are called floating point numbers. So numbers with a fractional component. JavaScript supports scientific notation, so like 3.1 E4. I think that'll give me 31,000. So if you're dealing with larger numbers, you might see that syntax. But We'll just keep it simple. But so Matthew isn't a valid identifier in JavaScript. But again, if I put it in quotes, right, then I'm using a string value Matthew. So now B contains a string. So it's kind of nonsensical to say something like if A is, equal to B, right? What would it mean for 5, a number, right, a numeric value that represents a quantity of 5, to be equal to a string, which is kind of in computer terminology, a sequence of bytes that forms the string. So that's right. That's just kind of an odd thing to try and think about, right? How is a number equal to a string? Well, JavaScript has, I guess you could call it kind of a convenience feature or something. 5 as a string, this is no different than Matthew as a string, right? I'm not really giving it the numeric quantity 5 here. I'm making a string, a set of text, right? Like I could say, 5 cats, right? The 5 here is part of my sentence. It's part of my text. And so taking the word cats off of that, but leaving it in quotation marks, doesn't affect that at all, right? This is still a string. B is a string, not a number. A is a number because it's just this number that has a value on its own. But in JavaScript, I can say A equals B, and we'll console.log A is equal to B. And then maybe we'll say else console.log A is not equal to B. Let's get rid of some of this other junk. So in almost any other programming languages that looks like JavaScript, the only equality operator is this, equal, the 2 equal signs. And the reason that it's 2 or 3 and not just 1 is because 1 equal sign in the programming language is already taken, right? That's the assignment operator. 1 equal sign means take the thing on the right and assign it as the value of the thing on the left. And because the way programming languages work, you can't really use the same syntax, the same thing, to mean 2 entirely different things. The equal operator is already taken for this case, for assignment. So programming languages had to come up with a different way to represent the equality test. And the way that a lot of them do it is with 2 equal signs, right? So if equal B means A is equal, test if A is equal to B, not set A equal to B. Of course, if you know other programming languages or anything about programming languages, you know that's a vast simplification. And there are, in fact, languages where you can just use a single equal for comparison testing. But, kind of in a lot of, I'd say even most programming languages that are in use, what I'm saying holds true. So anyway, that digression aside, we're testing equality here. So if A is equal to B, if the value that is inside of the A variable is equal to the value inside of the B variable, we want to run this code. Otherwise, we want to run this code. Now, when I run this in JavaScript, let's run it. It says A is equal to B, right? So this evaluated to true, and we ran this code. Now, if you're coming from any language other than JavaScript, that's kind of weird. If JavaScript is your first language, if you're new to programming, that actually may seem kind of intuitive, right? Sure enough, right? 5 is 5, right? They sure look equal to me. But if you have any other programming background, the idea that a string could be equal to a number is very unusual. this would be a bug in any other programming language. It wouldn't even let you try to do this. It'd give you an error, kind of some kind of type exception or something, saying, "Hey, there's no way to compare a number to a string." But we can do it in JavaScript. Sometimes that's convenient. Most of the time, it's covering up a potential bug, right? Why are you trying to compare a number to a string, right? It happens to work in this case, but if I change this back to Matthew, Matthew, of course, is not equal to 5. And so it says A is not equal to B. But if I'm trying to compare a number to a string, most of the time that means I've made a programming mistake, right? I don't want to accidentally get in a case where the string happens to be the string 5, and all of a sudden this comparison turns out to be true. So to make JavaScript behave more like other languages would, we have the triple equal comparison operator. And now the string 5 is not equal to the number 5. So A is not equal to B. And that's because I'm using this triple equal. So again, I'm still not going to get any kind of error by trying to compare what most languages would consider incompatible types, but I'm not going to accidentally think the string 5 matches the numeric value 5. So it's still a bit of a nonsensical comparison, and it'd be nice, in my opinion, that that JavaScript just consider this an error, but it's very loose when it comes to the type system, and a lot of dynamic languages are. Nevertheless, this will at least prevent something from accidentally matching based on coincidence. The fact that, this time around the string happens to have the 5 inside of it. But again, it's one of those things, unless you know you shouldn't, just go ahead and use triple equal when you're writing in JavaScript. And there are cases when you may want this behavior, although as a programmer, I would always make that more explicit, right? There are functions to turn strings of numbers into numeric values. So I'd always rather see that as an explicit step in the code so that I can tell, if I'm coming back to read this program later, I can tell, yes, the programmer wanted to translate, maybe a user entered string from a number into a numeric value for comparison. There's, the way you do that in JavaScript is if you say, B as a number, there's actually a number function that will turn a string into a number. And now this B as a number variable is a number. And if this string is a valid number, I'll get the numeric representation that matches that string. And then, B as a number, even with the triple equal sign, now that the types match, A is equal to B. So, right, again, in JavaScript, you can do that directly with double equal, but as a good programming practice, you would probably want to be explicit about type conversions so that when another program is coming along, they realize that's your intent, that it's not just some wild accident that you're comparing a string to a number and expecting it to be sensible. So now that we have these if statements, let me just make this slightly more sensical, right? So if the numbers match, we're going to print it's equal. If the numbers don't match, we're going to print it's not equal. Let's revisit that var versus let thing. So I'm going to put this in a function. Let's make a function called check equality, and it's going to take variables A and B. And I wrap that whole thing in curly braces. We'll indent it to make it look nice and readable. We don't need those anymore. So this is a function that I can pass two variables. And if they're equal, it will print out A is equal to B. If they're not equal, it will print A is not equal to B. And we can call that function We'll call it with 5 and 10, which should not be equal. We'll call it with 5 and 5, which should be equal. Note that we don't declare any types in JavaScript functions for the parameters. So here I'm passing numbers in. I could just as easily pass in strings. And again, it'll just, that triple equal operator for comparison works on any types. So I'd expect to print A is not equal to B, A is equal to B, A is not equal to B, and A is equal to B. So let's run that and make sure it works. Yep, not equal, not equal. Perfect. And again, just to contrive an example here. So variable scope. So if I say let's just make something new. Let C equal 20. I've declared this variable in this block. So this function, basically anything surrounded by curly braces is a block. This is the whole functions block. These curly braces make a block for what to do when this if statement is true. These curly braces make a block for what to do when the if statement is false. In this case, this let C equals 20 is at the top level of my function block here. It's not nested more deeply in any of these other blocks. So I can, I said let C here, down at the bottom of this function, I can say console.log, by the way, C is, and let's just concatenate C onto the end of that. Let's run that. Right, so every time I call the function, I'm doing this stuff, A is equal to B or A is not equal to B. And then I'm printing, by the way, C is whatever the value of C is, and that's 20. Now I've called this function 4 times, right? So I've, this C variable is, permanently set to 20 here, right? C is 20. If I'm out here and I say console.log C, will it print 20 since I've called the function that creates this thing called C and sets it equal to 20? Nope, I get an error. C is not defined. So this C only exists inside of this function. So any temporary local variables I need to do the work that this function is doing stay nice and contained inside of this function. They don't litter up other functions. They're not messing up what's called my global namespace. As far as the code is concerned at this point, C does not exist. C only exists inside of the function, inside of the block where I declare it. Now in a function, that will be true for var as well. If I run this code, C is not defined, but it exists inside of the function. So again, var and let look very similar. Let's take this away from here, though. And we'll get rid of that. Let's say inside my if statement, I say var C equals 20. So now, let's see, let's just go down to one that is equal, so we go down that code path. So I'm going to run this. We'll call check equality. We'll go into the check equality function. Because I'm calling it with 5.5, this is true. So I'm going to run the code var C equals 20, and then log A is equal to B. We skip over the else because the condition was true. And then we're going to log C, which should be set to 20. So let's run that code. Aha, it worked. Now again, depending on your programming background in other languages, that may seem a little bit odd because this variable declaration was inside this block. And in a lot of languages, that would mean the scope of this variable, scope meaning where this variable exists, what part of your code you can use it in. The scope of this variable would often be restricted to the block in which it's declared. But in JavaScript, when you define a variable with var, it bubbles all the way up to the function that it's declared in. So let's try that with let. Let c equals 20. Now refresh. Aha, c is not defined. Because even though I ran this code, because they are equal, and I let c equals 20, let keeps the scope of the variable limited to the block in which it lives. So when I got to that closing curly brace, down here, c no longer exists. Even though it's in the same function, it's not in the block that c exists. Now, if I move the c back up to here, it's in this whole function block. So even though I'm starting a new block here, right, c is still available because I can always see up to my outer blocks. So this if statement block can see everything in this function block. And then this function block, if I had a kind of global variable out here, the function block can see outside to whatever's above it. In this case, my global scope here. But things outside cannot see down inside inner blocks. So, right, let's just print out C here and C here. Clean up stuff we're not really using and run that. So here, I let C equals 20. Inside of this if code, I'm able to use C because it's available to me in an outer block. But before, when I had the let inside the if statement, it doesn't escape outside of this block. So this line down here can't see it. Again, that's different from var, right? Var bubbles all the way up to the function level. So even though it's in this block, it ends up being available after it's declared to everything in this function. So what's the rule? Unless you know you need that peculiar behavior of var, always use let. Because that helps you reason about, the reason I'm putting that C inside of this, just this if block is because I'm only using it for something local to this. I don't want to, have that escape and be out there when I don't need it. So use let unless you know you have a reason to use var. There's another nuance to the difference between let and var, but probably not super important to cover at what I'm trying to keep a pretty basic beginner level here. But again, that other nuance is a good reason to use let other than var. It can prevent accidental bugs in the code that can go unnoticed. So we get functions, right? We can have more than one function. I can have a function that says say hi. We'll just bring back our say hi function. Console log hello name. So I can check equality, and then I can say hi. And it will just run one function after the other as I call them. Functions, of course, can call other functions. So I can say, say hi, Matthew. From inside of say hi, I can call check equality. And let's say 5 and 10. And let's remove the check equality call there. Now, if we run this program, it should say hello, Matthew. And then because I'm still in the say hi function, it'll call this next line that checks the equality of 5 and 10, which should print out A is not equal to B. And sure enough, that's what it does. Hello, Matthew. A is not equal to B. It's because I called say hi, and then say hi called check equality. And check equality could call another function. You can actually get yourself into a loop the way I've written this, right? What if check equality calls say hi, Bob? If I run this, it's just going on forever. You can see it's loading. I just heard my CPU fan come on because it's just in this infinite loop. So that's bad. And in fact, here we go. So JavaScript finally hit what's called the maximum call stack size. So I got, I don't know how many hundreds or thousands deep into that loop. But, I said hi, which called check equality, which called said hi, which called check equality, right? I got in this infinite loop. And then once it's in it, there was nothing in the program to escape out of this loop until eventually I basically ran out of memory for JavaScript to keep track of where it is in the program, because it just got so deep into the stack of one function calling another, calling the one back, calling the other. Okay, so bad. You don't want to accidentally introduce infinite loops like that. But, it happens. So now we're back down to just what we want. Okay, there's another concept I'm going to introduce here that seems a little bit advanced, but it's pretty fundamental to how a lot of modern JavaScript code works and is written. So we know we can have a variable with a value. Functions as a value are just like any other value in JavaScript. So what does that mean? So just like I can say let A equals 5, I could say let B equals function, and then my function body, console.log, hello there. So I didn't give the function a name, right? Normally I'd say, function say hi, and I'd do my thing, and there'd be this function name here. But function on its own, without a name, and then you can still have a parameter list, it returns a value that is this whole function. And I've assigned whatever the value of the definition of that function is to B. So now B is something I can call like a function. So let's run that. And it runs this function that I assigned to the variable B. I said hello there. Right? So this code, these 3 lines here, 3, 4, and 5, are exactly equivalent to this code. Right? So what we're doing in JavaScript when we make a function is we are creating a variable with the function name, the variable here called B, which gets the value of the definition of the function. Not the result of the function, but the actual function itself. So I can do that same thing by making a variable called B and giving it the value of this function definition. So normally you do it this way, right? This looks like how you do it in most programming languages. But what's going on behind the scenes, these two things are equivalent. And you wouldn't necessarily do this like this at the top level. This is just to demonstrate. But it's important to realize that, if we do it this other way, we'll call it say hi again. If we call our say hi function, right? Okay, so this works. This is just how we've been doing it all along. Maybe I make, now let's just say let B equal say hi without the parentheses. I'm not calling the function. I'm just saying the actual definition of the function, right? So that's a very important distinction between calling the function by putting the parentheses behind it versus just getting the value that represents the definition of the function. And now I can do say hi. I don't know why it expanded to that. Or I can also call B, because now B is entirely equivalent to say hi. So it should say hello twice. Yep, it did. So keep that in mind. There are a lot of places in JavaScript where you actually pass around functions as a value versus calling the function. So JavaScript has a lot of built-in functions for things like finding items in an array, or applying a function to every item in the array. And the way those functions work is you actually give it the function, basically the variable representing the function that you want it to use to do further work. You'll also see a shortcut for this notation. So let's delete all of this. Right, so I can say function add numbers, a and b, and we're going to return a plus b. So very simple and unnecessary function, but that's my function. And then if I console.log add numbers 1 and 2, it should print out 3. Also, I don't know if you noticed what I did here, right? So there's a couple ways I can do this. Let's just prove that works. Save that, print that out. Right, so if I were being a little more step by step, I might let sum equals add numbers 1 and 2, and then I print out the value of sum. And of course that prints 3. But I can skip a step, right? I'm able to take that function call with its parameters, put it inside of my log function call, and now when JavaScript is running through this, it's going to hit this line. It's going to say, oh, okay, I need to do this console.log thing. What do I need to send in to this console.log function? It says, first I need to figure out what this add numbers 1 and 2 is. So it will run this function. It will remember the return value of the function, in this case 3, and then it will pass the 3 along to console.log. So console.log will pass 3. Right, so you can make these nested function calls like this. Again, for something simple like this is pretty readable, right? Okay, I'm calling log. The parameter to log is whatever the result of this add numbers function is. If I'm passing if this is something that takes a lot of parameters, or if this function call to add numbers, right, takes a bunch of parameters and has other functions that you're using inside of it, right? As these things become more complicated, then, just style-wise, even though it will always work to just nest as many of these things as you want, this is when you think, okay, if I'm another programmer or myself tomorrow and I don't remember what I was doing, right, and I can make a little more clear what's going on by just breaking this out into a couple more steps, right? Let's make a temporary variable here to say, sum, and that's where I'm going to move this function call with all of this going on. And then I want to print that result. So I just have a simple console.log message that prints out sum. So just think about if your program is more clear to you and others and your future self when you're coming back to maintain it, right? Does it make sense to break it into more discrete, explicit steps? Or is it a simple enough scenario where just doing the function call like that maintains clarity, you understand what's going on, you don't think anybody's going to be confused about what's going on, in which case you can just do the more compact form like that. Entirely functionally equivalent. It's just a style implication and a code readability implication in terms of what you think makes sense. Okay, so there's a syntax you're going to see a lot in modern JavaScript code, and that's what I was getting at demonstrating here. So I have this simple function, add numbers a and b, and it returns a and b. And again, we've learned how functions like this work. We should all understand this now, I hope. The other way you might see this is back to that idea of let's make a variable called add numbers, and let's set it equal to, and in this case, I'm going to say a and b equals, and the greater than sign, a plus b. Okay, let me comment this out so we can reference it, but now this is commented out, so it's just totally ignored by JavaScript. Let's see what happens here. I still get 3. Okay, so this is a function expression syntax. And I guess the best way I can describe it is that this is exactly equivalent to this, if it were uncommented, of course. Right? I'm saying I want a function. I want to be able to call it with 2 parameters, and I want it to do this. Now here, the return statement is implied. I could put that explicitly, I think. If I put this in I think I have to put it around curly braces. But we can make it look a little bit more like our traditional function there. Let's comment that out again. Yep, still works. Now it's looking more like what we had before. But this is a shorthand notation to kind of define a function that takes parameters and does work in place. And this gets back to that, what I was talking about, where in a lot of places in JavaScript, you're actually going to pass a whole definition of a function, not calling the function to get its result, but you want to pass the function itself as a function type, as a function object to other code, to other functions. And that's where you're going to see this shorthand notation of a function expression. Again, this could be, if you want to, test, maybe, is big, and it's going to take 1 number. If I only have 1 parameter, I don't even need the parentheses, right? We'll make it explicit. We'll call this input number. And we're going to return, is the input number greater than 100? So now I can call isBig as a function, give it an input number, and I will get back a true or false value depending on whether or not the number is bigger than 100. So let's try that. IsBig 200. I won't delete that yet. Yes, 200 is big. Is big 99? Nope, 99 is not greater than 100. Is big 100? Do you have a guess? It's false, right? We're checking for greater than 100. 100 is equal to 100, but it's not greater than 100. If we want to include 100, we can say input number greater than or equal to 100. Now it's true because 100 is indeed greater than or equal to 100. So don't let this equal greater than confuse you. This is not checking equality. This is not checking if something's greater than something else. This is just a magic little syntax that says, hey, I am declaring a function that takes this as the input and provides this as the output. So think of this almost as like transforms, right? You're taking an input and you're transforming it to the output of the function. So it's going to transform 100 into the value true, right? This is a little machine that input number goes into and gets turned into this value, which is true. But again, this line is the same as if I wrote the function out this way. And in this case, we're going to return whether input number is greater than or equal to 100. All right, so if we comment out this other way, my little console log is big here is still going to work the same way, whereas 90 should be false. Okay, so I bring this up not because you should declare all of your functions this way, right? As you're making your functions, write them like this. But as soon as you start watching tutorials, as soon as you start looking at sample code, whenever you see this equal greater than, because there are a lot of places where this is kind of the legitimate correct way to write a function that you're dropping in a specific spot. And oftentimes it won't even have a name, right? It'll be what's called anonymous. It's just this anonymous function expression, but this will be a parameter that you're passing, to something else. You might literally be passing this function into another function call. So there's no need to give it a name because you're never going to reference it again, but you want this I'll call this my other function. Whatever this my other function is, right? This isn't something that exists, but if it did, you're wanting to let it be able to evaluate this function, but you're not using the function anywhere else in your program, so there's no need to name it. There's no need to, declare it and define it out here as a function. It's just this anonymous little snippet of logic that you're kind of creating and then passing in on the fly to something else. So when you see this, whenever you see this equal greater than thing, right, if it helps, you can always rewrite it so that you can understand what this function is doing, right? So copy and paste it. Whatever's before the equal greater than are the parameters to a function. So you just put the word function, give it a name. You can just, give it anything just to get it into the syntax. Put parentheses around the parameter list that's before this. That little equal arrow thing turns into your opening squiggly bracket, curly brace. And then, of course, you'll need to provide a closing curly brace. And you can start, formatting this over multiple lines so it starts looking like a function. If it's just a bare expression, right, you can make it more clear by understanding, okay, this function is returning that value. And you can always just mechanically turn something like this into this, which might be a good thing to do until you wrap your head around just seeing that and instantly recognizing, oh, okay, it's a function that takes input number and it's going to return is the input number greater than or equal to 100. These can have curly braces with lots of lines of code. So that looks and usually be formatted something like this, where the closing parenthesis is right after that, and something like that, right? So now this anonymous function I'm passing in, can have all sorts of code, right? It can say console.log, I'm in the anonymous function. It can, it can let something new, let something equals 52 plus input number, right? I can print out console.log input number plus 52 is, and then put something on the end of that. Then at the end of all of that, I can be explicit here that I'm returning is that input number greater than or equal to 100. So this whole thing is a function definition that this other function could use. Now, for fear of, again, getting too advanced, because you're not in your initial JavaScript programs, you're probably not going to write your own functions that take other functions as parameters. But just to round this out and show, kind of that, yeah, this actually works, let's actually write that my other function. And this is going to take a function as an input. So I'm just going to call that input function. And let's say, what does my other function does? It calls whatever input function is provided with the value 42, right? So I can now call input function with the value 42. And who knows what happens, because my function has no idea what this input function is going to do. But it's going to call whatever it is, and it's going to pass a number to it, 42. I always like things to sort of be in the order that, so the declaration makes sense. So I'm going to define the function before I try to use it. Sometimes that's important. A lot of times in JavaScript, things get hoisted up so you can use them kind of out of order, but I think it makes more sense in my mind to say, okay, I'm going to make this thing called my other function, and then I'm going to use my other function. So this is probably getting messy and a bit confusing, but let's just go ahead and run this and see what happens. Okay, so I called my other function, and I didn't just give it a number. I gave it a whole function I then want it to in turn call. It called that other function, whatever I passed in, which is this anonymous function, with the number 42. And so it then ran, I'm in the anonymous function, yep. It added 54 to 42, and it said input number plus 52 is something. That's the other thing I declared. Yep, sure enough, input number plus 52 is 96. And then it returned whether the input number is greater than or equal to 100. We didn't do anything with this, but if we said let is it bigger equals that, we'll get that back out of let's see. Yeah, we'll get that back out of here. At least I think we will. I'm looking at my own code now. So this is my anonymous function returning. Yep. Okay. Yeah. So this will then say, is it bigger? Right. And then we could have code out here that says, if is it bigger, we'll print something out. Console log. It's bigger. By the way, another reason I tend to use double quotation marks instead of single is because, in actual text, I use apostrophes all the time. So it's more convenient to use double quotation marks there. And is 42 bigger? No, so it shouldn't print as bigger, but if I change this to a big number, it prints it's bigger. Okay, so again, this idea of passing functions as values around is kind of advanced. So you don't worry if you're not fully wrapping your head around it yet. The important thing is that you are going to run into code that uses these function expressions with this this equal greater than syntax, this kind of whatever I called it, right? This little transformation definition. It's called a function expression. We may as well use the actual technical term from the language. So just realize that that's what it's doing. It is creating a function. The things on the left, right? And there can be more than one of them. The things on the left are the input parameters that the function takes. And then the thing on the right, which if it's more than one line can be in a block like this, but it may just be not in a block and just be a single statement if it's just a really simple function, is the function body. So again, right, I can just easily turn that into the function syntax that we understand a little bit better by just taking it all, putting the word function on it, giving it a name, again, adding the parentheses if I need to around the parameter list, take out the equal greater than. If there isn't already a curly brace, add the curly braces. And now it just looks exactly like any other function that we already know how to interpret, how to understand. Okay. I am all over the map, but one last piece of JavaScript I want to show you for today. And maybe forever. This may just be the bare bones basics. Maybe not teach you from scratch, but maybe just be something that after you've looked at a little bit of JavaScript, hopefully this video just fills in some gaps and clarifies some basic concepts for you. The idea of objects in JavaScript. So again, this is about types again, right? So A is a number, B is a string. We actually have, Booleans are their own type of thing. So C is a Boolean. It can be true or false. What else do we have? We saw that variables can actually be functions. So here's a function that does absolutely nothing, but D is of type function, in this case a void function because it returns nothing. And if memory serves, other than objects, those are the basic kind of primitive types in JavaScript. There are some special cases. So so null is a special value in JavaScript that indicates the lack of any value. So E is null. Null is a special word. On the math side of things, there's actually not a number. So not a number, this NaN, it is a number value, but it indicates that it is not a number. So that may seem kind of weird, but it becomes relevant with certain math operations and being able to check if what you got out of something is in fact a number. In fact, does JavaScript, if you divide by 0 in JavaScript, is that illegal or does that give you not a number? Let's see what happens. Oh, so it actually gives you this other special value, which is infinity. So infinity is a special number type. Generally, dividing by 0 isn't infinity. It's actually an undefined operation, but whatever. That's how the language chooses to interpret it. But anyway, sorry. Again, I'm just going all over the map. I should have written an outline or something for this. The types, the primitive types are these. Maybe there's one or two others I'm not remembering. But a really important type is an object. So an object, let's make an object called Matthew. And I'm going to set that equal to, and I'm going to put it in curly braces. And I can say, I can start giving attributes to Matthew. So attributes look like variable names, and they can have values, blue. And maybe, my lunch today was, let's say, a burrito. What else can we say? So those are strings. I might say, we can say age, 39, give that a number. So I've defined this object, which is a variable called Matthew, and it has these properties: favorite color with value blue, lunch, burrito, age 39. And so I can do things like console.log Matthew's favorite color is, and I can say Matthew.favorite color. I'm going to turn on word wrapping here so we can see all of this while we're using the big font. So Matthew's favorite color is Matthew.favorite color. And of course, you're going to see dots like this all over JavaScript, and really any vaguely object-oriented programming language. And so what is this doing? Well, I have this variable called Matthew, and this variable happens to be an object, and that object happens to have these properties. So it's how I get to things inside of objects. So because Matthew has something called favorite color, I get to that by saying Matthew.favorite color. And that will give me the value blue. Let's run that. And sure enough, it works. Matthew's favorite color is blue. Change favorite color to age. Not type in the middle of it. Change favorite color to age. And it prints out 39. You can make this a little bit more readable by separating these over different lines. This last brace can be on the same line or a different line, right? So I kind of rearranged things, but the code is functionally equivalent. It still works. So you can get to those things with this dot notation. Objects can be nested. What does that mean? Well, Matthew has a car. What's a car? Well, a car might be another object. And that car might have properties like make. Let's say I have my Tesla model. It's the Tesla Model 3. Right? So Matthew has a property called car, and the car has properties called make and model. So I can say something like the make of Matthew's car is Matthew.car. That gets me inside of car, and then dot make gets me down to this particular property of car of Matthew. Let's run that. The make of Matthew's car is Tesla. Okay, so you're going to see all these dots strung together. That's basically just going deeper and deeper inside of these nested objects and accessing, these are arbitrarily named, right? I just made these up. Obviously, lunch and favorite color aren't, magic words in JavaScript. These are basically just like making up a variable name, right? Just like I can say let favorite color equal red, right? I made up a variable called favorite color. Here I'm making up a property, which is you can think of as a variable that's specific just to this Matthew object. I made that up, called it favorite color, and set it to blue, right? And so if I say console log Matthew.favorite color, I get blue. there's no conflict with my other variable out at this scope here called favorite color. These are entirely different things. And so I can say console.log favorite color, and it's red. Because this favorite color is this variable called favorite color. Matthew.favorite color is the property on the Matthew object called favorite color. And the last bit of that, and maybe this will make a couple other things click, like what's happening here when I say console.log. Right? So there's something called console, and it has something called log. But log looks to be a function because I can call it. Sorry, I messed that up there. So sure enough, remember where we said, I can assign a variable the value of the function itself, the definition of the function. Let's say, I have a property on Matthew called what was for lunch. That can be a function, and that function can do things. Now, I want to return what Matthew had for lunch. The way I get to the properties on the object that I'm actually executing under is with the special word called this. So what was for lunch? Let's print console.log Matthew had, or I'm trying to make this grammatically correct no matter what I put, but whatever, that's not important right now. Matthew ate for lunch, colon. And then I can say plus this dot lunch. And because this is a function on the Matthew object, this refers to the Matthew object. So I can get at this lunch up here by saying this dot lunch. And now we can call Matthew dot what was for lunch. It's a function call, so I put the parameters on it to actually, or the parentheses on it to actually call that function. And this Matthew object now has a function attached to it called what was for lunch. So let's run that, and sure enough, it works. It does exactly what we thought it would do. All right, that function can take parameters, of course. Matthew ate for lunch that's just going to make the example confusing. It won't make any sense. Matthew ate for lunch a burrito, and it was so silly, but let's say I pass in a value here, tasty, right? So I'm passing in the word tasty to this a parameter of this function that's on Matthew. And we say Matthew ate for lunch burrito. It was tasty. Again, you need to get kind of your spaces right so that when you string all of these together, it comes out looking okay. Matthew ate for lunch burrito. It was tasty. So that's a very quick introduction to objects here, but you'll see that a lot. I'm realizing now I left out one really important thing that's probably, it has to be included in kind of the basics here, which are arrays. So let favorite numbers equals, and then square brackets. So these are the kind of brackets we haven't used yet. My favorite numbers, I don't know, 42, 37. What sounds good? 111. So this is an array. It's a variable that holds more than one value in these square brackets, separated by commas. This is if I want to kind of declare this all ahead of time. And the way I get to individual items in the array is with square brackets and then using an index. And the indexes start at 0. So the 0th item is 42. Item number 1 is 37. And item number 2 is 111. So this should print out 42. This should print out 37. And this should print out 111. Right? So it starts at 0. You just have to remember that and adapt to life starting at 0, or you'll have what are called off by 1 errors. And that is, of course, common enough in computer programming that there's a name for it, off by 1 errors. So I can print out the second item in the list, which is index 1, because we have index 0, index 1. So I can print that out, and we'll get 37. I can change that. So favorite numbers, index 1, I want to change to 195. Now if I console log favorite numbers, and I look at index number 1, it should print 37, and then because I changed it to 195, it should print 195, which it does. So let's get rid of that. So arrays are useful when you need to hold a list of similar things, right? They should have some meaning in terms of why they're together, how they're together. And this gives us an opportunity to look at a couple of looping constructs, right? So we saw if. If will do something if it's true, otherwise it will do other things. While will keep doing something as long as the condition is true. So let's say, we'll leave favorite numbers aside for now. Let's say we have a variable called time left, and we're going to set that to 30. Now, we've been doing this all in one line. Keep in mind, I can declare a variable like that, and then I can set it on a different line, right? So sometimes you know what it needs to be from the start. Sometimes you just want to bring the variable into existence with a name because you're then going to give it a value later, either because the user's going to input it, and so you need somewhere for user input to land. So you create that variable ahead of time, and then you assign to it later. So either way works. So while we can put the condition inside parentheses, just like if, and we'll say as long as time left is greater than 0, and then we'll give it a block to run. We will say console.log, still going, and then maybe, time left, just so we can see how it's progressing. Now, if I wrote this like this, right, if I ran this right now, we would be in another infinite loop situation. Time left is 30, which is greater than 0. We're just going to keep printing out still going 30 forever. And unlike that function call infinite loop, this will actually never end. See, it's just, this is the console's way of telling me that this same message has been printed out this many times. So this is just going to go forever. It's not going to run out of memory like the function call thing, because function recursion takes memory to keep what's called the stack going. But this is just executing this one line over and over and over and over again forever. So let me stop that if I can. Chrome is basically crashed here. Don't know how to stop that in Chrome without closing the window. Well, okay, let's... Yeah, see, this is why infinite loops are kind of bad. How do you stop a task in Chrome? Okay, well, let's fix the code first, and then we'll worry about that. So, of course, what I intend to do here is, I want to count down by 1 each time. So I'm going to change time left to whatever it is, but minus 1. Right, so eventually it'll get down to 0, and then we'll get out of this function. We'll say, done. Okay, let's refresh. We're just going to have to close this Chrome window, I think. Wow, I actually do not know how to easily kill... There we go. Yeah, so that was just 100% fully utilizing Chrome in that infinite loop. Okay, let's open that back up. Let's open our lesson back up. Let's open our DevTools back up. Okay, so now we get what we want. Still going, it counts down from 30 to 1. And if we reload there, we see that happens. It basically happens instantly because we don't have any delay or anything. And the computer can subtract 1 in mere microseconds. But that's how a while loop works, right? As long as this condition remains true, it will just keep running whatever's in the block over and over and over again. And so you better have something in the block that is eventually going to make this condition no longer true, or some external event that can influence this condition. So the other thing from a while loop, kind of a shortcut for doing something like a countdown like this, is a for loop. So a for loop, its condition takes 3 parts. It allows you to set an initial kind of setup condition. So usually use something like I as your loop variable. So I'm going to make this thing in the scope of this for block, this for loop, called I, and I'm going to set it to 30. And then I'm going to provide the condition to keep going. So this is kind of like the while loop, right? As long as I is, let's say, greater than 0, we're going to keep going. And I'm using semicolons to separate these 3 important parts of the for loop. And this third thing is what I want to do each time I go through the loop. In this case, I'm going to take that I and I'm going to subtract 1 from it. So this is how I'm eventually going to get out of this loop, right? Eventually, having subtracted enough from I, 30 will be 0, and I'll leave the loop. So let's console.log. Still going. We'll show what the current I is, and then after we'll say all done. Okay, so let's reload that. And sure enough, it works. Starts at 30. Each time through the loop, we're subtracting 1 from I. And eventually, I is no longer greater than 0, so we don't re-enter the loop. We leave the loop, and then we just run the rest of the program, which in this case says all done. So this isn't quite how you'd normally see for loops written. Again, depending on what you're doing, you often start at 0 and count up. So I'm going to start at 0, and then I'm going to say while we're less than 30, and instead of subtracting, I'm going to add 1. So now I'm going to get the same thing. I'm going to get the same number of times through the loop, but we're going to start at 30. We're going to start at 0, and we're actually going to go up to 29. So instead of 30 to 1, which is 30 items, we're going to go 0 to 29, which is 30 items, because 0 now counts as an item. Okay, so I just ran that, and sure enough, we start at 0, we go up, we've gone through the loop 30 times after we've hit 29. Now, the reason I say we typically start at 0 is because more often than not, for loops are used to go through every item of an array, right? So if I have an array of numbers, let's say I want to print out all of my favorite numbers. Well, I'd say, okay, we can do that with a for loop. I can iterate over this array. And I'd let I equals 1, and this is called my counter or my index variable, right? This is just a temporary variable I'm using to index into the array through the loop. And I want to keep going as long as I is less than the length of this array. So I have 3 items in this array. That's the length of the array. Remember, this is index 0, index 1, index 2. So 2 is less than 3, so that'll be valid, right? I can call item number 2. But if I get up to 3, 3 is not less than 3. 3 is equal to 3, but 3 is not less than 3. So this loop will never try to ask for item 3 in this array, which is good because item 3, index 3, does not exist in this array. Only items are index 0, 1, and 2. And then each time I add 1. So I can say console.log 1 of Matthew's favorite numbers is, and then we'll say favorite numbers at the index of whatever my loop variable is. Okay, let's run that. There we go. One of Matthew's favorite numbers is 42, 37, and 111. So what's the problem here? Well, what if this becomes longer? 76. It's still only showing me my 3 favorite numbers. Where'd 76 go? Well, I terminated the loop after printing 3. I'd have to move that up to 4 for the new array length, and now I get all 4. Now maybe that's what I want, right? Maybe I want Matthew's top 2 favorite numbers, and if we assume I put them in here in order of preference, right? That could be intentional. My 2 favorite numbers. Doesn't matter how many favorite numbers I have, as long as I have at least 2, I'll get my 2 favorite numbers. But if I want all 4, right, I kind of have to keep that in sync. What happens if I only have 2 favorite numbers, but I, wrote this code to kind of print out the top 4? Uh-oh, we get this undefined value. I've asked for something from the array that doesn't exist. Well, that's a bug, right? I don't want to show a user that. Luckily, there's a simple solution to this. I can ask an array what its length is. Right? So I'm going to go from 0, and I'm going to go until I is less than the length of the array, and I'm still going to add 1 each time. Perfect. If there's 2 items, it prints out 2. If there are 3 items, it prints out 3, and so on and so forth. You can imagine where this goes, right? So it will always loop through every item of that array and do something. The other thing you'll see is I'm being explicit here. I'm saying I is equal to I plus 1. You would always just see that as I plus plus. This is the increment operator. So this just always sets the variable that you put it next to 1 more than that variable currently is. So it doesn't change the function of the code. It does the exact same thing. We can see how that works. Let's make my number equal to 10. Let's print out my number. And then let's say my number plus plus. Now let's print that number again. Starts at 10. Plus plus is exactly equivalent to saying my number equals my number plus 1, but it's saving you from having to repeat yourself with that my number thing, right? We can do it again. You already know what this is going to do. Now it's going to say 10, 11, 12. Okay, so it's a shorthand. When you're going up by 1 through a loop, you're pretty much always using that shorthand because, again, that's almost always what you're doing. There's a minus minus, so my number minus minus will decrement it by 1. It's the decrement operator. So that brings 12 back down to 11, right? So if there is a case where you're not going from 0 on up, right? If I want to go in, the opposite order, I might start at the length of the array, favorite numbers length minus 1. And that's a trap, right? If you're wanting to start at the end of the array, it's the length minus 1 because, right, again, the length is 4, but I want to start at index 0, 1, 2, 3. So length minus 1. And then I'd say I is greater than or equal to 0 because I want to include index 0. And then instead of I++, it's I minus minus. Let's delete all of that. And if we run that, now I start at the end of the array, and I'm making my way back down to the beginning of the array. So I've just reversed the order of that array by starting at index 3, going through the loop as long as my index is greater than or equal to 0. So I be sure that equal makes sure I get index 0. And I go from, in this case, 3, and I subtract 1 each time, 3, 2, 1, 0. And then I'm done with the loop because I is, this I minus minus on 0, the next time through the loop, I will be -1, which does not pass this test. So we leave the loop and we print all done. Phew. Well, I had no idea what I was actually going to cover and how long it would take, so I probably went too long and covered things a little bit too randomly. But I hope that is useful to someone out there just in terms of, never really worked with JavaScript before. What are some of the basics? What do some of the different syntaxes mean? What can I do with it? How do I make a little function? How do I call functions? How do I work with variables? What's that funny function expression syntax that I see everybody using in all of the tutorials that I'm following? Those are some of the very, very basics of JavaScript. Again, we haven't looked at, okay, now use this code to start modifying this HTML and doing things on the web page. This is just pure JavaScript. And with that, hopefully it starts making sense when you do start, modifying HTML, or you're doing something like console.log. It's like, oh, okay. Console is, this variable that's an object that has this property that's a function called log, right? I can make those things myself. I can make a variable called, Matthew that has a function called log. And in this case, that function is just going to, call console.log with whatever something text I provide. But now we have Matthew.log. Hello there. I have my own log function. Will that work? Yep. Hello there. I have my own log function. So everything you're using in JavaScript, right? Everything that the web browser gives you, everything the language gives you, it's all built up from these, kind of simple principles of how everything is glued together and put together. And you're using what's called the standard library or the library functions. That's all the code that's already been written for you to do things like this console.log, like all of the functions you're then going to use to find HTML elements and change their text, or read values that users have put into input fields or clicked buttons. Right behind the scenes, it all kind of boils down to this is how JavaScript works. All right, I will end your suffering now. Like I said, hopefully that's helpful. Maybe some light bulbs lit up, but mostly I'm just hoping to give some background so that when you start seeing certain things like arrays and going through arrays, and there are other ways to build iterators around arrays, right? You're going to see more stuff in JavaScript to do this in some different ways. But these are just kind of your basic types of loops. We looked at that if and else. We looked at variables. We looked at making functions. So hopefully this is a good foundation. Thanks for sticking through it all. And if you have any questions, let me know.